Welcome to this video on the topic of networks. In this video, we're going to have a look at how we can deduce the maximum flow within a network using something called the Flow Min Cut Theorem. Now this theorem is analogous to the proverb we use about the strength of chains, that being a chain is only as strong as the links it is made of. So if you have a look at this little picture over here, what you can see is there's a paperclip in the chain. And even though the rest of the links in the chain are quite sturdy, this paperclip is the limiting factor here. If the paperclip can't hold a certain force, then the entire chain or the entire system fails. Now this is similar to a network. The flow in a network is restricted by the lowest capacity links that connect the network, or the lowest capacity arcs. Now if we draw our attention to the diagram that's seen over here, what we've got is what appears to be a mostly linear network. It's composed of 4 nodes, the source S, alpha, beta, and the sink T. Now observing this network, to be able to understand the maximum flow in the network, what we do is we look for the bottleneck or the weakest links. In our case, the 220s, they're not going to be our bottlenecks, but rather these two inner links over here. So the 7 and the 11. So what we're going to find is that the flow within this network here is dictated by the 2 weakest links, or the 2 lowest capacity arcs. Now one way of thinking about finding the maximum flow in the network by looking for bottlenecks is you can think of it as the maximum flow in a network may be found by deducing the combination of arcs within a network that when removed will disconnect the source from the sink. So in our case, when we remove these 2 nodes or these 2 arcs over here, we're effectively breaking the network or disconnecting the network. Now the lowest sum of the arc capacities of removed arcs will yield the maximum flow. Or in other words, if these 2 arcs over here, if we remove them, the sum of these 2 arcs will give us 18, which also happens to be the maximum flow within the network. So effectively what we're looking at is how we can break a chain, and the links that we remove, measuring the strength, we're able to deduce the maximum flow. So in our case here in this chain, the maximum flow would be the strength that this paperclip can hold. Okay, so let's have a look at a non-trivial example. Down here we've got another network. It's composed of 6 nodes and 1, 2, 3, 4, 5, 6, 7, 8 different arcs. What we're going to do is we're going to use the algorithm shown up here, or the theorem shown up here, to be able to deduce the maximum flow within this network. What we're going to do is we're going to look for the combination of arcs that will disconnect the source from the sink. Now, looking at this, the first move we can make on disconnecting the source and the sink is we can remove this arc and we can remove this arc. Performing this, I'm going to get a little liner. I'm just going to cut like so, and then I'm going to write C1. So this line over here represents that I'm cutting the forward moving arcs, so here and here. So that's the first one we can do. Now another cut we could make to be able to remove arcs is we can cut through S and C, A and C, and A and B. We'll call this C2. So we're cutting this arc here, we're cutting this arc here, and we're cutting this arc here. Reason we're cutting this guy over here is because if we're observing the network flow, we could get a situation where it goes up like this, down like that, and down like that, evading the cuts here and here. And we don't want that. We want to be able to completely disconnect the source and the sink. Okay, so that's C2. Now another cut we can make is here, here, and finally here. And we'll call this C3. So we're going to be cutting this arc, we're going to be cutting this arc, and we'd also have to cut this arc over here. So we're cutting SC, AC, and BT. Alright, so this exhausts all of this one. So let's have a look at CD. To be able to cut or disconnect the source from the sink, starting in the middle, we're going to go up. Then we're going to divert across. So we'd be disconnecting this arc over here, this arc up here, and it would be this arc over here. Removing these 3 arcs would disconnect the source from the sink. Next one, cut straight upwards, C7. So what we've got are 10 unique ways that we can disconnect our network by removing particular arcs. Now the next step is we need to trace the routes for disconnecting these, or disconnecting the source and the sink, and then we're going to sum the arc capacities of the arcs that we remove. What we're going to find is that the arc, or the arcs that we remove, the sum of the arc capacities is going to reveal to us the bottleneck within the network. So doing this, C1 is going to be this node here and this node over here. This arc and this arc. So that's SA plus SC, which will sum to be 18 and 21, which is going to sum together to give a value of 39 units. In this case, we don't actually have a C6, forgot to include that, so we go straight to C7. Okay, now we've got all the capacities of all the cuts that we could do. So the cuts being the sum of all of the arcs that we cut out of the network to disconnect the source from the sink. What we're going to do is identify the smallest. Now the smallest in our case is going to be C1. And as a result, the maximum flow is equal to 39 units. Now, understanding why this algorithm actually works is, well, it's quite a good thing we got this solution over here. What we're looking at is we're looking at removing these 2 arcs over here. Now, the reason why it works by picking the smallest of all of the cuts is that when you think about it, at any given time, the traffic throughout this network, or the flow throughout this network, has to flow through every single one of these cuts at any given time. Now, in terms of if we were able to flatten this network into just a single line like so, then the single line itself is going to be the smallest because we're looking at the bottleneck here. Now, in terms of looking at it in this particular network, what you can see at any given time, the flow in this network has to go through this arc up here and this arc up here. And the maximum capacity that these 2 particular arcs are able to hold is going to be a total of 39 units. And that's why this particular theorem works, by observing which of the arcs we can remove to disconnect the source and the sink. So in summary, what we had a look at in this particular video was how we can apply the max flow min cut theorem. And then we did 2 examples of it.